Well, first of all, welcome, and thank you so much for having me. This is kind of my first developer talk, kind of officially. So if I am, if I miss anything or skip over anything, or if you feel like I need to slow down, speed up, just let me know, and I'll do my best to keep tabs on it. But I'll start just by introducing myself. So, my name is Frank Foster. I am starting a job at Rocket Mortgage as a developer tomorrow, actually. I've been a developer at Gleason Technology for the last year, and prior to that, I was in IT. So, I was a transition from IT to I to iOS development over the course of the pandemic. So that was kind of my claim to fame. I've been involved though with programming for about 3 years through the University of Idaho, through a program called Inspire Idaho, which is a program for adults trying to move into a different career path, um, who aren't able to either afford college or who are, um, you know, working, can't be able to attend classes and things like that. So I've been doing coding for about 3 years, specifically in Swift. I'm also part of iOS Dev Happy Hour for those of you who've attended. If you haven't, we can talk about that later. But another great event that's part of the community. But today I wanted to talk a little bit about Swift and reactive programming, not React Native or React, but reactive programming. So to kind of start things off, we first want to understand what is reactive programming and its relationship to Swift. So Swift by nature is an object-oriented language, and as such deals with objects passed inside the architecture. So there's one inherent challenge with this approach that can lead to a series of headaches, like memory management and threading, as well as synchronous and asynchronous calls. Now, working in Swift with smaller sets of data can be pretty easy, but things get complicated quickly when we have to handle asynchronous calls or network data or other complicated sets of data that can change en masse or frequently. I'm sure everybody's worked with an API before where you've got stuff changing and moving all the time, and it can be kind of challenging. So, especially if you have to get the dispatch queue involved with handling those calls, and especially for newer developers, it can be kind of a challenging thing to wrap your head around all that. So, reactive programming is sort of one of those things that is there to help bridge that gap and make things a little bit easier. So, what is reactive programming? To start, it's a library for composing asynchronous and event-based programs by using observable sequences. So it extends the observer pattern to support sequences of data and or events and add operators that allow you to compose sequences together declaratively while abstracting away concerns about things like low-level threading, synchronization, thread safety, concurrent data structures, and non-blocking I/O. So ReactiveX, I got this from ReactiveX, which is the sort of central database for all of the reactive frameworks for every language. You can find them at reactivex.io, and they point out not only RX Swift, which I'll be focusing a lot on in this talk, but Reactive Swift and even a little bit of Combine is mentioned on their site. But they have a lot of great resources that I'll talk about later on learning this a little bit further. So the idea with reactive programming really is to monitor data streams that can be observed and assigned reactions or subscribers. So you observe the data with a framework, a reactive framework, and you don't really have to rely as much on the dispatch queue to handle asynchronous data or data that changes rapidly, but rather rely on some of the reactive methods that are provided. So, namely the process of observables to monitor and make changes to the code or views. So, in Swift, this means that we use those libraries like RxSwift, Reactive Swift, or Combine to assist in creating observers to observe the streams of data and subscriptions to manipulate that data asynchronously. So, an observation and a subscription to observe. So, that kind of gives us that definition of reactive frameworks. Let's move on to some of the building blocks of those frameworks. So to pause for a moment. A lot of what I'm going to be talking about going forward is going to have a focus on RX Swift, since that's where most of my experience is at. However, this does translate well to Combine, reactive Swift, and I think there are a few other reactive frameworks that are out there. So to begin, let's first look at a few of the basic building blocks of reactive programming as seen through the lens of RX Swift. So the first building block that we have is our observers. So these are objects that observe our data stream. An example would be, say, an API call that's giving us an array of data. So an observer would be something that observes that data stream. So the next is a subscriber. So this is a method by which the observers are then manipulated and translated to our needs. So once we've observed that object, we can subscribe to them within our views and be able to manipulate them. So again, say we have an observation of an array and we need to put that into a table view. The subscription is what we would then assign that table view those updates and those changes. Lastly, we have our dispose bag. So while there is a lot that's handled within the frameworks, the dispose bag is sort of an RX Swift little magic bag that basically handles memory management and deallocation of resources to a subscription. So as you subscribe to data streams, the dispose bag handles cleaning all that up for you at the end. Combine, unfortunately, doesn't have this feature as far as I'm aware of. This is sort of an RX Swift exclusive piece, but there are methods within Combine that can kind of do the same thing that dispose bag handles. So let's start with the idea of observables, sort of to better understand how data is propagated. So observers rely on essentially what is known as a sequence of data. So if we look at this graph, we can see a line that represents our data stream. And as we send data through that stream, we'll have our different points of data, in this case letters, represented by these dots. So we have A, B, C, and D coming through that data stream from an API, let's say. Who knows if you're doing an alphabet API? I'm sure there's one out there that just sends you alphabets and letters and characters. But as that data propagates through the data stream, it then completes, and it results in what we would expect to be an array of A, B, C, and D. So it's a very simple idea. The observable within this pattern is observing this data stream and seeing these different pieces of data come in. And once the data completes, it formulates an observable item, in this case, an array of A, B, C, and D. Now, observables are not exclusive to arrays of data. You can use them for singular items, for singular variables. They're usable with any type of data. You can have it with strings, ints, doesn't matter. Passes through the whole thing. So what's different that's happening here, though, is that even though in the example we have 4 pieces of data, even if we have hundreds or thousands of data, the observables, as they're observing that data stream, are doing the work asynchronously. So we don't need to declare this on the main thread. We don't need to not declare on the main thread, but we don't need to worry about handling this in a dispatch queue or waiting for a certain event to occur. We can basically just say, hey, we want to observe this data stream and do something with it. So it's kind of a beautiful, magical thing that the observable does, all under the hood of those frameworks, and more specifically within RX Swift. So it's a beautiful kind of magic that happens with our observables. So now that we've got our observables, we need to worry about doing something with them. So that's where our subscriptions come in. So unfortunately, with observables, we aren't able to just reference that observable and call it a day, and we need to actually have some sort of handling of that data stream as it's being propagated. So with our subscriptions, we're able to subscribe to those observables and be able to process certain outputs and apply certain methods to it depending on your needs. So within our observable, we essentially have three different, or within our subscription, I should say, we have three different methods that we can call on the subscription. So the first is onNext. So every time an observable emits an item, when a value is added to the stream in the order it was received, onNext is called. So this is useful when you have an array that's emitting an item every time. Let's say, again, that ABCD, onNext would be called every instance of that ABCD emission from the observable. The second is onError. So this is when an error is emitted from the observable, say a network connection failed, or it didn't receive the observable it expected, or any sort of error. That's sort of your error handler is onError. So this ceases any further onNext processes or any further onComplete calls and terminates the observable sequence. So it's nice in a sense that the onError basically handles if that error occurs, you do have to do some manual management of what will happen with that error, rather than it just crashing and saying, whoops, everything's done, goodbye. You have that error handling. So the last is onComplete. This is called when the stream has finished all of its items, it's completed that array. It's useful when an API is completed sending its data and you need to perform a completion handler. So this is, hey, once all these items are complete, send them to a different place or display in an item, or, print out, hey, it's done, it's completed. So that's the purpose of onComplete, is to handle those completion handlers. So we now have our observables observing our data and our subscriptions that are subscribing to the data. But once we're done, we need to do a little bit of cleanup. Now, the problem that we do run into with subscriptions is that they do retain in memory until the moment that they're finished with these objects, and they'll essentially stay in memory until we declare some sort of end to their process. And we could use these handlers, but the most efficient way is to use something called the dispose bag. So again, this is more of an RX Swift thing, but it's just a management way, or a method to handle memory management within the subscription. So to kind of talk briefly about the dispose bag. So the dispose bag is used to remove the stream from memory, so to remove those subscriptions from memory, and it terminates the subscription when all of the data has been received. So right after, once we've received all the data from that API, we've got A, B, C, D in, and the subscription says, okay, we're done, we've received all the data, what do you want us to do now? Our best bet is to use the dispose bag. The really neat thing is that the dispose bag can be used as sort of a pseudo singleton, in the sense that you can subscribe to multiple streams. Say we have an observer observing a stream of letters, and then we have another one observing numbers, and then we have another one observing, images from an API. You can have one dispose bag that handles disposing of multiple streams at once. So that way you don't have to declare multiple instances of the dispose bag or have specified dispose bags if you don't want to. So it's kind of a neat way. So with the subscriptions, we do have a caller called disposed, or .disposed by dispose bag. It's the final method caller for handling subscriptions to point to a dispose bag object. So this is where you can take that one dispose bag object, you can actually just declare it as a variable and have everything pointed to that dispose bag object and say, hey, when this is done, when we've completed this stream, send those disposals to the dispose bag. So the other call that we can make is onDispose. So it can be called at the end of a subscription to perform a function, or when something is disposed of. So this is similar to that onNext, onError, onCompleted for subscription. So those are both of the different methods that we can use to call and utilize the dispose bag. So we've got our observers observing items. We've got our subscriptions that are subscribing to those. We've got our dispose bag for cleaning all that up. So the next piece is, how does this all fit in? Well, when we look at RX Swift in particular, and most of these frameworks, they really prefer utilizing MVVM as the framework or as the app architecture behind these choices. So that's where MVVM kind of comes in. Now, it makes a ton of sense to use, as MVVM does divide up a lot of the pieces of RX Swift and reactive programming into the different sort of sections. In fact, reactivex.io does point to MVVM with Swift as sort of the primary preferred method of handling building your app around reactive programming. However, that doesn't mean that you can't use other app architectures like MVC or Viper, or I believe there's even some work being done within Swift UI and kind of some of its work, so that you could utilize something like RX Swift within those kind of different view types and methods. In fact, I know Combine at least is built with Swift UI in mind, so there's some crossover with other app architecture. So it's just important to note that if you haven't used MVVM but you do want to use reactive programming, it's very important to kind of look at MVVM as the app architecture that you might decide to use for your app's architecture with reactive programming. So in moving forward, I figured we'd jump away from the slides a little bit, and I'd actually show a little application that I've built just to showcase what it looks like in play, and I can kind of explain those pieces sort of in a live method here. So let me see if I can switch over to my Xcode. Is everyone doing okay so far? Okay. Perfect. All right. Can we all see this okay? Okay. So within this, I've got a very simple app. This is just a table view. I'm using the Pokemon API to access and display a list of Pokemon names. I figure with all the Polyworks stuff going around, if everyone's seen all the Pokemon references there, I figured that would be a great place to start with something simple. So right here, I've got all the usual suspects. I've got my app delegate, my scene delegate, which is unchanged, my view controller, my data source for my table view, my data model, my model, and then my network API requests. So kind of starting here, we'll start with the API requests. The first thing that I've done is import my RX Swift, and I've created two classes. One that's our request, and one that's our call. So the request is very basic. We just have our base URL, our method, parameters, and a request pattern here. But then within our API call, we have our function that's going to send our object. So as we receive that API request, we're having it return an observable type of the type of data that's returned. And then we're processing it as a JSON, just like we would, utilizing the model Pokemon data, which in our model, this is our results type here. And I've only built out our model with just our name, so I don't really need much beyond that. And then as far as if it creates any disposables, it cancels the task. So we have our error and our completed and our next here. So on next, it's going to put those results as our type. It'll catch any errors, and it will send a complete on our observer once that is sent. So if we jump back to our, I believe it's in our data model here. So within our model, we have our variables for our call and our request. And we have a private variable that's an observable type of an array of Pokemon, which matches our model here. So we have our array of Pokemon, which is going to be our different item types. And this is just going to return an API request. Then the last thing that we have here, and this is probably the most important, is that as this takes that API call and sends it based on the request. This will return, when we call Pokemon source, an observable array of Pokemon. So this, we then want to take that observable array, which is our Pokemon source, and we're going to use an RxSwift method called flatMapLatest, which basically takes our map of objects and it just puts them in order received. So once we receive those in that order, we're then sending it as an observable item with the .just. So this is saying only return our resource type. So we're just returning a series of observable objects that are Pokemon. So with that said, we can hop to our view controller and we can see where I've declared a data model, which is referencing our table view data model. And I've got just a simple table view here that I've built programmatically. And within here, we have our subscription. So within the subscription, we're basically referencing that variable, that Pokemon variable from our data model. That's this guy right here. Get it right here. And we're going to subscribe to that variable. And it's important to note that I do declare weak self within here, because as we subscribe, we don't want to have any cascading memory issues with self. And then we have our array of items. So this return type here, or this return object, is going to allow us to throw it into whatever we want to do with it. So I've also declared these down here just so that you can see the calling, see the full list of things that you can do. But really, this could all be deleted, and you could just run it like so. So they're not necessary, they're just there. So right now I just have it doing a few prints and showing it there. And then the last thing I have is my disposal. So once this subscribes to that object, it creates that array, and once it completes that process, then it will be disposed by my dispose bag, which I've declared up at the top here. So the only thing I've really created in here is an update method within our subscription, which is right down here. And you'll notice I do have it in a dispatch queue. That's purely just one of the unfortunate pieces of doing it this way with our data source. But essentially, all this is doing is referencing another method that I have called submit data in my data source. And all this is doing is just assigning that new list of objects to another array that's of our normal type Pokemon, and then putting it within our cell. So we have the cell name being updated here. So I've also noted that this is sending the full object of Pokemon. So since we're only referencing name, if I do update the model at all, I can update down here. I've also added sort of this explanation here that's saying, like, if you were to create a custom cell, you could create some sort of function that then allows you to pass that Pokemon into that cell, so you can just reference those Pokemon objects within that cell, following that same MVVM style. So that way you could send entire model objects in one way, but this is just a cheap and easy way just to get that object into that, or get that name into that title label. So going back to going back to the view controller, we've got our table view gets reloaded, and then that should pump all the data through. So if I were to, I think I am going to have to show my whole screen just so that we've got the actual thing here. Let me just switch to that real quick. If it'll let me. Oh, here we go. I'll go ahead and run this so we can see it. Using an iPod Touch because I like to stay current with my devices in my simulator. As you can tell, this is the first time I'm running it today, so I know it works. It should work, unless the Pokemon API is down somehow. But what we should see happen is that our API request should get called. We should have that subscription, and we should get our prints from all of our objects here. Come on, M1 Mac. You're supposed to be quick. There we go. So there we go. There we've got our list of Pokemon names. You can see that it completed, it disposed of the objects, or disposed of the subscription. And if we were to leave and relaunch, it should do the same thing. We can try and run it again just so you can see it in real time here. Boom. So there it pops in. Awesome. So does that make sense to everybody? To have any other questions? Or I guess we'll get to questions here in the end, but I figured I'd at least stop there and jump back over to my presentation here. All right, so that's pretty much it. I think that RxSwift and Combine and other reactive methods are a much more efficient use of asynchronous programming and handling network data. So I would encourage you. Here's some resources that I've kind of put up here. And oh my gosh, I left my insert repo here. I haven't put it up yet, but I will put up the repo of the code that I just showed, so everyone's got an example of it. But these are excellent resources for RxSwift, for the reactive libraries, for Combine, and I also mention Donnie Wall's book on Practical Combine. I personally haven't read it yet. I have it sitting in my list of things to read, but I've heard excellent things about Combine, and Donnie's book is supposed to be one of the best resources for it. So here are some excellent resources. And kind of at this point, I hope that I've been able to show you all just what I've learned and what I've been excited about reactive programming and sort of its use. But if you have any questions, that's pretty much it. Yeah. Thank you. No, that was just me being tired and up late and forgetting to put my repo there. And I updated the repo today, but I forgot to make it public and posted there. So I will put it in there, and I will make this available. I will probably share it on my Twitter. For those of you who don't follow me, it's just at Frank E. Foster. Yeah, I'll make sure that this is shareable and that everyone can see it and see the resources. So yeah, thank you. Perfect. Hey, Michaela. Hmm. So I can say I've been using RxSwift for the last year. It's what we used at Gleason for our project. I feel like there's pros and cons to each. The pros of RxSwift that you have is it supports all the way back to iOS 10. So if you want to retroactively add it for older users, it's a great framework for that. As well, it's RxSwift has been around for quite some time, and it's the more preferred over reactive Swift for like third-party frameworks. And I don't personally see it going away anytime soon, especially with it being as supported as it is. Combine is another weird one where it's iOS 13 forward, so you can only use it with those iOS versions. But it is Apple, so the hope is that Apple continues to maintain it, Apple continues to update it, and that you have a lot of support there. So I think it really just depends on which approach you want to take. If it, in a perfect world, if it was me, I'd say look to Combine, just because it does have more integration with Swift UI than RxSwift at the moment. But that's not to say that Arc Swift might not catch up with that and be a little more fleshed out. I do see Arc Swift in job postings a lot more than I do see Combine. So if that gives you any sort of gauge there too. Yeah. Oh, that's awesome. All right. Sure. Exactly. Yeah, and the beautiful thing about the observable pattern is that it's not restrictive to any sort of class or type. So you can have observables on pretty much anything. You can have it on a custom class, you can have it on a custom object. So it is, not as restrictive in that matter. And I think that's where the MVVM kind of comes in, where you can create those data models and have references to those, as opposed to trying to cascade it. I know one method that I've used as well is using dependency injection to make sure that you've got all of the models and everything moving in the right way. Um, but oh my gosh, my brain just kind of stalled there for a second. But yeah, that's a good point. Is that you do have that flexibility with most of these frameworks. Thank you. Hmm. Yeah, that's a good question. Let me see. Let me hop over to my code real quick, just to show kind of what's going on here. And I will be completely honest in a way too, in the sense that I haven't explored every possibility that the dispose bag can handle. So I may not be speaking from a complete point of authority on this, but essentially what's occurring here within that data model is that the subscription occurs, it grabs those objects, and then going back to that graph that I had of the line where it creates that completion, it says, okay, we've received all of the data. That's when the completion occurs, and then immediately after that is the disposal. So this is basically just saying, what object do you want this to be disposed by? So on disposed is basically just saying like, hey, maybe I want it to print this disposed thing, right? Or maybe I want it to update some other view or do whatever, right? But this is basically pointing to that singular dispose bag object that I have here. Now, I could put that dispose bag anywhere. Since it's a singular object, I could have this dispose bag within my data model or my data source, or I could have a central, I could declare a class of dispose bag that just has a dispose bag and have it handled there if I wanted to, just so that there's a singular call for dispose bag. I did it this way just to keep it simple so we could see it in the code. But there's no rhyme or reason to it. You could even, um, oh my gosh, if my keyboard doesn't want to act up, you can even do this. You can just declare write to the dispose bag right there, but it should. Oh yeah, Mm, that sounds correct. That sounds correct. Yes. In my circumstance and using it, this was the method of how I was utilizing it. So again, I could be completely wrong in this implementation, but I believe Yichin. I can't. What was how do you pronounce your name? Yichin. I believe you are correct in that if, for example, this subscription persisted after the view was destroyed, the dispose bag would not get called as it gets destroyed before the view is able to complete it. So there may be a better implementation of this method. But this is just the method that I've used and that I've seen. And I should probably let my previous team know that maybe there's an updated way of doing it. Perfect. Thank you for clarifying on that because honestly, that's not something I was as familiar with. Awesome. Thank you. Hey, just like any project manager, we got to set expectations, right? Awesome. Thank you. I should do like developer nighttime stories and just be like, and the view controller had a table view. Well, thank you. Thank you. Thank you.